All right, and away we go. Now time for a little bit of a gear shift. We're going to go section 2.8, way back in the beginning of your book again. Distance, midpoint, and some information about circles. All right, yeah, let's get there. With me, Mr. Hain. All right. So let's derive the distance formula. So what is the distance formula? The distance formula specifically is looking at this question. In the coordinate plane, how far apart are A and B? Why not know? So we're going to have to add some stuff to this drawing. By connecting them with a third point C that's directly below A and directly across from B, we get a right triangle. So that lets us define the length AB. Now AB is the hypotenuse of that triangle, so we can use the Pythagorean theorem. Oh my gosh. All right, so the Pythagorean theorem states that side C is going to be A minus C. That's going to give us A. And then side B, which is here at the bottom, is going to be B minus C. Okay, cool. So if I were to give these points, then I would have x2 minus x1 squared plus y2 minus y1 squared, and I would take the square root of all of these to find the distance. And there you go. We have derived the distance formula in the coordinate plane. So let's apply it. Checkpoint 1, real simple. We're going to put that into the distance formula that we know. So 1 minus -4 and -3 minus 9. Now the order really doesn't matter. I could have done -4 minus 1 and 9 minus -3. I would get the exact same answer. 5 squared plus 12 plus -12 squared. Of course, when we square them, we get the square root of 169, which is just 13. Sweet. All right, why don't you try this one? Pause the video and come back when you found the distance. And now that you're back, here we go. Did you get the square root of 41? Now you might think to yourself, what? Square root of 41? Why isn't mine neat and nice like Mr. Haynes' example here with the 13? Don't worry, it's the same thing. It's just an irrational number. You're fine. All right, so let's talk about the midpoint formula. How do you find the middle of something? Well, you define the middle by dividing by 2. And how do I find the number between two numbers? Well, I just add them and divide by 2. So if I have 2 points on the coordinate plane, all I'm going to do is just use them and add the x's together, divide by 2. Add the y's together, divide by 2. Kaboom. Now I got to simplify. 8 divided by 2 is 4, comma, -1/2. This point is in between these two. If we wanted to take some time on a coordinate plane on a piece of graph paper and draw those out, you will draw a straight line between 1, 2 and 7, -3, and you'll find that 4, -1/2 is directly on that line and exactly in the middle. Boom. All right, so let's talk about circles. Now these are going to be the heavy lifting portion of today. Now for circles, we can define the center as h, k. Now, why is it h, k? I have no idea, but it's h, k. And then we're going to define the point on the edge of the circle as x, y. All right, cool. Now, you might think, now if I collect these two, I have the radius. It is the radius. And the radius then would be 2 points in a coordinate plane. We find it using the distance formula. Oh my gosh, radius is just x minus h squared plus y minus k squared, and the square root of everything. Now, that square root does not look sexy, so I'm just going to square both sides, and here I have r squared is equal to x minus h squared plus y minus k squared. Booyah! The standard form equation of a circle. Sweet. So what we can do is you can write the standard form equation of a circle if I give you some points. So the center's at 0, 0, and the radius is 4. It's fairly simple. Substitute it into my standard form equation of a circle. And y squared plus x squared plus y squared is equal to 16. All right, let's get a little bit more complicated. That was too easy. More on circles. Let's find the center and the radius of this circle. Now, you might notice that this circle actually has an addition, which here in the standard form equation, it has subtraction, which means what I'm going to do is actually rewrite that orange equation using the standard form equation of a circle using subtraction. So subtracting a negative would give me a plus 3. And of course, here you see I take the square root of 4, which is 2 squared. All right. This gives me the center and the radius. I think we can actually find more, though. We could find the domain. Now, recall if I have the center of a circle here, the domain is all the possible x values inside of that circle, which means I take the negative 3 and I'm going to add and subtract the radius, which is 2, from x. So negative 3 minus 2 and negative 3 plus 2. Boom, that gets me the domain. And if I can find domain, I can absolutely find range by doing the same thing, but to y. And the y value here is 1. So I'm still adding and subtracting the radius. And you see here 1 minus 2 and 1 plus 2. And that gives me the range. Boom! I have found from one equation the center, the radius, the domain, and the range of that circle. Oh man, so powerful. So let's write the equation in standard form. And we want to find center, radius, domain, and range. And we're going to use this equation. All right, what the heck, Mr. Hain? Look, this is all jacked up. It's all black, and look at it. It's all weird. It's got x's in multiple places and y's. Okay, calm down. We got this. We're going to double complete the square. Oh, yeah. So I'm going to add the 1 to the other side. Give me some space. Boom. Okay, fair warning, I'm not a super adept with PowerPoint, so you're going to see me kind of like fudge some stuff here. But I'm going to complete the square with the x first here, so this should be an x. I'm going to just subtract or square here. So I've got 4 divided by 2, which is 4, and that comes to both sides. So I'm going to add the 4 to both sides, and again, this should be an x. And then I'm going to do the same thing with this 4. 4 divided by 2 is 2. 2 squared is 4, so I'm going to add that to both sides. So 1 plus 4 plus 4 is 9. And then both the x and the y quadratics can now factor to plus 2. Why plus 2? Because this is a plus 4, so I have a plus. And 4 divided by 2 is 2. Boom, that's how I get these. You'll notice here in blue, I actually now have the standard form equation of a circle. So I'm going to rewrite them using the subtraction sign and square rooting the 9. And that gets me the center. You'll notice the center in this circle is actually negative 2, negative 2. This is going to come up later. Now to find the radius, again, I took the square root of the 9, and we see that it's 3. So that's the radius. I can find the domain and the range together because x and y for the center of the circle are the same. And subtract and add the range to that, and I have negative 5, 1. Now that's the domain and the range for that circle, and only because the center is negative 2, negative 2. Boom. All right, so why don't you try this one? Remember to move that 9 to the other side before double completing the square. Go ahead and pause the video while I take a sip of tea, and you'll come back. All right, and we are back. Did you get this as your equation for the circle? Sweet. Its center is 2, 6. The radius is 7. That's the square root of 49. Domain, I'm going to add and subtract from the center, from the x value in the center. And range, I'm going to add and subtract from the y value in the center. Boom. Sweet. You know what, guys? Sometimes it's just easy, short, and sweet. Rewatch the video if you need to, but until next time, that's distance, midpoint, and some stuff on circles with me, Mr. Hain.